Hey guys, today we're going to graph quadratic equations. Okay, well, let's just talk about quadratic function for a minute. So we have a quadratic function in the form y equals ax squared plus bx plus c, standard form. Okay, and the graph is a parabola. Okay, so let's just talk about some characteristics. All right, so first, if I have a parabola that looks like this, it has, we've called it a vertex. Okay, for this particular parabola, it is also called a minimum. Okay, it has roots or x-intercepts or solutions. Okay, then it also has a vertical line that cuts the parabola in half. And this is called the axis of symmetry. Axis is just another name for a line, and symmetry means that it does cut it in half. Okay, so you can have a parabola that looks like this. This is a positive parabola or a positive a value. We could have a parabola that looks like this, has a negative a value, and it too will have an axis of symmetry, a vertex, roots. The difference in this parabola is the vertex here is a maximum because it's the highest point. Okay, so if we have a positive parabola, has a low point or a minimum is the vertex. If we have a negative parabola, it's facing down, the vertex is a maximum. Okay, all right, so I'm going to give you guys a very specific way to graph. Just learn the steps and be able to follow them. All right, it says for each equation, find the axis of symmetry, then find the vertex, then graph, and then be able to identify the roots. Okay, be able to identify the roots. So first, to find the axis of symmetry, it's a simple formula. X equals negative b over 2a. So we're given the parabola, or the quadratic, y equals x squared plus 2x minus 3. And to find the axis of symmetry, so the axis of symmetry, if you notice, they're vertical lines. All vertical lines have the same form, x equals a number. Okay, so I'm going to write here vertical line, axis of symmetry. So the formula is x equals negative b over 2a. So x equals b, so sometimes I like to write a, b, c, negative 2 over 2 times 1. It's negative 2 over 2, which becomes negative 1. So x equals negative 1 is the axis of symmetry. Okay, so first step, find the axis of symmetry. Done. Okay, then we're going to find the vertex. Okay, so to find the vertex, we plug in the x-coordinate of my axis of symmetry into my equation. So my equation was y equals x squared plus 2x minus 3. Okay, so we need to figure out what y is when x is negative 1, because the axis of symmetry was x equals negative 1. So I'm going to plug negative 1 everywhere there's an x. So negative 1 squared is 1, minus 2, 2 times negative 1 is negative 2, minus 3. So 1 minus 2 minus 3 is negative 4. Okay, so x is negative 1, y is negative 4. So there is my vertex. Okay, now the next point I would like to get is what is y when x is 0. Okay, what's y when x is 0? Okay, so I'm going to plug in 0 for x. Okay, so y. This one's usually easy, and you guys are going to see a pattern here. It's going to help you do this quicker. 0 squared is 0 plus 0, y is negative 3. So if you notice that that is my c value, okay? So when x is 0, y is negative 3, okay? So then I need a couple of other points, right? So I'm just going to do when x is 1 and when x is 2, okay? So to get these, so you could use your calculator. I'm just going to show you quickly by hand, but whenever you could plug 1 squared plus 2 times 1 minus 3 into your calculator, and it would give you the answer, okay? And we see that y is 0 when x is 1, okay? And then finally, I will need one other point. I want to see what y is when x is 2. 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. Minus 3 is 5. Okay, so I've got some points. Now, this is always a good idea to know how to graph this way, because if you don't know what the graph looks like or you don't know how to get points, just plug in some x values and you can get some corresponding y values to get some points. Okay, so let's graph these points, all right? So I have vertex of -1, -4, then I have 0, -3. You can see that's the y-intercept. 1, 0 is a point, and 2, 5 is a point, okay? So you can see that we have half of our parabola. Well, we do know that the vertex is where the axis of symmetry passes. So I'm going to use that to get some other points, all right? So since that's the axis of symmetry, what I want to do is I want to reflect these points. So I'm going to take this point and reflect it to here. I'm going to take this point, it's 2 away from the axis of symmetry, I'm going to reflect it. This point's 3 away, I'm going to reflect it. And you can see, doing that, we get the other half of our parabola. We get the whole thing, okay? So we get our graph. So I graphed the points from my table, and I reflected them over the axis of symmetry, okay? And then finally, I want us to identify what the roots are, okay? I have one root at -3, 0, and I have another root at 1, 0. Okay. So notice the steps. Calculated or found the axis of symmetry. Then I found the vertex. Okay. Then I got some points on my table. Okay. I just went to the right of the vertex. I went -1, 0, 1, 2. Okay, and I plugged in x to get y. Then I graphed those points. I reflected them over the axis of symmetry, and then identified the roots. Okay. All right, let's look at a next one, and got symmetry misspelled a couple of places. That's not how you spell symmetry, either one of them. That's funny. Good thing I don't count off for spelling. All right, first it says graph the quadratic equation, find the vertex, the axis of symmetry, and the roots. Okay, so this is what we do. We find the axis of symmetry first. So it is definitely helpful to remember x equals -b over 2a. That's the formula for the axis of symmetry. A, B, C. So -b is -4. 2 times -2. Negative times a negative is a +4. 2 times negative 2 is negative 4, and that equals negative 1. So x equals negative 1 is my axis of symmetry. Okay, use that to find the vertex. So I want to know what the value of y is when x is negative 1. So in my equation, I'm going to plug in negative 1 everywhere there's an x. So negative 1 squared minus 4 times negative 1 plus 6. Negative 1 squared is positive 1 times negative 2 is negative 2. Minus a negative, this would be a positive 4 plus 6. 4 plus 6 is 10. 10 and a negative 2 is 8. So y is 8 when x is negative 1. Okay, so my vertex is negative 1, 8. Okay, so before I can get my roots, I'm going to come down here and I'm going to use my table. So I'm going to start with my vertex at negative 1, 8. Okay, then I'm just going to go to the right. So negative to the right of my x. So negative 1's x, so I'm going to go 0, 1, and 2. Okay, so when x is 0, this is always a trick here, not a trick, just a shortcut. When x is 0, if you come up here and look, anything x here 0 would be 0, that would be 0. So c is the value for y when x is 0, so 0, 6. That one's always easy, okay? So don't do too much work there. Then I need to see what y is when x is positive 1. So I'm going to plug a positive 1 in. Everywhere there's an x. Negative 2 minus 4 plus 6. Negative 6 plus 6, y is 0. So when x is 1, y is 0. Okay. Then finally, I'm going to plug in a 2 to get one other point. Everywhere there's an x, I'm plugging in a 2. 2 squared is 4. 4 times negative 2 is negative 8. Minus 8 plus 6, so you get negative 16 plus 6 is negative 10. Okay, negative 10. So 2, negative 10. All right. So now let's just simply graph those points. So negative 1, positive 8 is my vertex. Okay, 0, 6, my y-intercept, 1, 0, and then 2 all the way down to negative 10 is my other point. So you can see that we have half of our parabola. The axis of symmetry goes through the vertex. So I'm going to reflect each point over that axis of symmetry to get the other half of my parabola. And it looks just like that. And the last thing we need to do is identify our roots. So I have 1, 0 is a root, and negative 3, 0 is a root, where it crosses the x-axis, the roots, the solutions, okay? So notice again the steps. We found the axis of symmetry using the formula x equals negative b over 2a. And then we used that x value to find the corresponding y value. And that's our vertex, okay? Then I used the vertex as my starting point. I went to the right, 3 x values, plugged in x to get the corresponding y values to get 4 points. I reflected those 3 points over the axis of symmetry to get the other half of my parabola. So notice this one, the vertex is a maximum because it's the highest point. Okay. Hopefully that helped. If you need to, watch it again or go back and watch it to help you out. Otherwise, get started on your assignment